Okay, so 7-8, this is the last chapter. Our test is going to be up and coming here. 7-8 is our last lesson in this chapter, and it is subtraction of mixed numbers with borrowing. Okay, quick review on borrowing. You can have a number like 48, which is bigger than 29, but it still creates a problem when you are subtracting, even though this one's bigger. Why? Because can you take 8 minus 9? No, so you have to borrow from the 4, right? It becomes a 3, you add that 1, and now you can do your work. 18 minus 9 and 3 minus 2. The same principle is going to apply when you are subtracting mixed numbers. You're going to run into that same problem where in the upper one, the numerator is going to be smaller than the numerator on the bottom number. So what you're going to have to do is you're going to have to be able to figure out how to rename mixed numbers. So let's just take it easy and get harder. If I have 7, a whole number 7, I could also rewrite that 7. I could borrow 1 from it and make it 6. And I could rewrite the one that I took away, right? It could also be 6 plus what? What would be an example?
7.
It could be 6 and 7 sevenths. Or it could be 6 and 4 fourths. Right? All of those equal 7. Do you understand that part? 7 is the same as saying 6 and 5 fifths. Because that's a whole and that's 6. Does that make sense? We kind of already did that. But what happens if I have 6 minus 3 and 2 fifths? Let's look at this. How many fifths do we have here? 0. Can we take 0 fifths minus 2 fifths? No. So what do we have to do? We have to borrow. We're going to borrow 1 from here. We're going to take 1 away from this side. And then we're going to add it to this side. Well, what are we going to add here that equals 1 whole? This is the biggest thing you need to figure out. Look at the denominator. We're talking about fifths. So what can we add since we took 1 away? What fifth equals a whole, Peyton? Right. So 5 and 5 fifths. Now we can say 5 fifths minus 2 fifths equals 3 fifths. And 5 minus 3 equals 2. Does that make sense? Let's do one more. We're going to get 2 steps harder. So let's try one more of those. We've got 13 minus 7 and 4 sixths. How many 6 do we have here?
2.
No 6. So we can't take 4 6 away from nothing. We changed this to 12. Since we took 1 away, we borrowed a whole. How can we write a whole right here so that it helps us? How do we write a whole? We don't just write 1. Some people started doing that, right? No, we don't do that. What do we do, Bria? Right, we say 12 and 6, 6. That's the same as 13. We just broke it down. We just borrowed it. 6, 6 minus 4, 6 is 2, 6. 12 minus 7 is 5. And then we say, oh, we can reduce this. They're both even. So it turns into 1/3. 5 and 1/3. Now, let's get 1 step harder, and then you will have this. It seems complicated, but it's really not. Let's take 4 and 1/3 minus 3 and 2/3. Okay, now we've got some thirds here. The problem is that they're not enough. 1/3 minus 2/3. Can you do that? No. So you have to? Yes, you absolutely have to borrow. So you take 1 away from here. This becomes 3. And what are you going to add? I like to put it in a little parentheses because now you need to add it to this to get enough thirds. What do we add? If we're going to add a whole, we took the whole away and we're going to add it to here. So Jackson, what do we have? You add 3 wholes? 3 thirds. Put this in parentheses because what happens is sometimes people just change this to 3 thirds. You have to add 3 thirds. Does that make sense? You borrow 1 from here and 1 whole is 3 thirds. So you have to add 3 thirds to what you already have. You already have 1 third. I need everybody's pencils down and I need everybody's eyes up here, okay? This lesson's a little bit too complicated to have you working on other stuff while you're trying to listen. So 1 third plus 3 thirds. How many thirds did you end up with in total? 4 thirds. Do you get how we got that? Yes. You had 4 and 1 third. You took 1 away from here and added it here. Well, you have to actually add that. And you get 4 thirds. Now you can kind of cross that out so it's not confusing. You have 3 and 4 thirds minus 3 and 2 thirds. 4 thirds minus 2 thirds equals 2 thirds. 3 minus 3 equals 0. Some people say, well, but Ms. Van Zanten, this is improper. Yes, that's exactly what you're doing. You are going to have to sometimes make an improper fraction here so you have enough thirds or enough whatevers to subtract with. This is the new part. So what gets confusing for sometimes, y'all, is what they do is now this was an easier one because the denominators are the same. Let's back it up. The final step, this is the hardest problem that you will see on your test for this chapter. Let's do an example like, here we go. Let's try 8 and 3/8 minus 5 and 3/4. Okay, here we go. First step that you always do in every fraction problem ever, always from now and forever is to do what? Everybody should know the first step. Find a common denominator. You cannot add apples and oranges. There are no such thing as orples, oranges, and apples mushed together. You have to find a common denominator, which is what? Shepherd, what's our common denominator? 8. This is an important step. This is where some of you, oh, I'm going to do it in my head. Oh, I'm going to do like messy work here. What I need you to do is I need you to rewrite the entire mixed number. Don't just rewrite the fraction because people forget about the whole number back there when you do all these steps. The most important thing, when you rewrite your fractions with a common denominator, rewrite the whole thing over again like this. Rewrite a whole new problem. Well, how many eighths? 8 and 3/8 equals 8 and 3/8. That one you didn't need to change. 5 and 3/4 becomes 5 and how many eighths? What did you do to the 4 to get 8? Multiplied by 2. What do I do to the 3, Zachary, to get my new number?
Multiplied by 3.
What did you do to 4 to get 8?
Oh, 2.
Yes, so you multiply the 3 by 2 and you get 6. Okay, so there we go. That you already knew, right? Girls in the back, that part you already knew. Find a common denominator, write equivalent fractions, and now you subtract. Now here's where we run into our new problem. 3/8 minus 6/8. Can you do it?
No.
Nope. Here we go. Borrow time. Let's borrow 1 from here, and that becomes a 7. And now what are we going to add? We're going to add a whole. What would that be? 8/8. We're dealing with eighths. So a whole would be 8/8. So don't forget this. Add these two together. This is where some people get lost. You have the 3/8 that you originally had, but you're adding 8 more eighths. How many eighths do you end up with? 11 eighths. And then I'm going to cross these out because otherwise it gets confusing. I like to keep it all neat. 7 and 11 eighths minus 5 and 6 eighths. 11 eighths minus 6 eighths equals 5 eighths, and 7 minus 5 equals 2. 2 and 5 eighths. Now, is there anything in your mind that you're like, okay, this is where I get lost? Or do you think you've got it? Okay, then let's get out page 120 and 119 and let's correct that and see how well you did.